We can start this point now. Then okay, today we can try the other method, but as we mentioned that we have two methods for the minimization. Then Kahneman method is the second one. We already tried this Boolean algebraic methods for the minimization. Then we'll start new one. Okay. And today we are going to discuss about the Kahneman method. When we take a variable, you know that if this variable is having two forms. One is that A, the other one is A bar. This may be 1 and this may be 0. Okay, it's having two forms, two states like that. Then in the Kahneman, it's very simple. So graphical representation is there to show these two status. For example, we can take this one, assuming this is a map, and we have A bar and A here. For A bar, we have one square. For A, we have another square. Okay. But here, as a technical term, we don't use square here. It's a grid. In the map space, all these things are grids. But with single variable, we can't do anything. Then we will move into two variables. One, A and B. Here we have two variables. Then you know the combinations. A bar, B bar combination will be there. And then next one, A bar, B, and A, B bar, and A, B. Those are the combinations we are having. Example, this is 0, 0. This is 0, 1. This is 1, 0, and 1. It covers that all combinations available. Then here, we need a map with 4 grids. Okay. This is side A. Side A, we have A bar A. And this is side B. And here we have B bar B. Okay. This is the map for 2 variables. Okay, then let's try this one with an equation. Okay, we'll take one equation. sample 1. Assume that you have an equation like this. A bar B bar plus A B bar, then A bar B. Okay. Then this is the equation we have. Now we want to minimize this one. First step is we want to mark our equation on the map. Then how can we mark this one? Okay, here you know that when you have this map, okay, these are the relevant one. Discrete is A bar B bar is this one. This is A B bar. This one A bar B. This is A B. When you have any of these 4 combinations, you can mark all these things on the map. Likewise, here we can try this one. A bar B bar we have. Then we put 1 here. Okay. Why? Because we have in our equation, we have A bar B. Next one, A B bar. A B bar. Here we have this. Third one is A bar B. A bar B is this. Now we have 3 terms. Then we covered 3 grids. But only 1 grid is remaining. That is not with our equation. Then we put 0 there. Now we have to minimize. To do the minimization, what we want to do is that we are going to group this. Okay. Then we start group in this one. Then we can make a group like this. Then after that, we have to name it. If it is possible to give a name for this group, that means that you have marked group correctly. What is the name for this group? Actually, we have taken the entire A bar row. Then we give name for this group is A bar. What is remaining? This one is remaining, then this is along. We can take it as a single one. Then what is name for this one? This is A B bar. Okay. Then what is the minimized equation here? F equals A bar plus A B bar. Okay. But you can see here, but we have make groups combining these 2 together. But what about if we can make a group like this? If we make group like this, then what is this? Can we give a name for this one? Yes, this is B bar. Why? We have occupied entire B bar column. Then this group is B bar. Then this is alone. We can take it alone. Then what is the name for this one? This is A bar B. Then equation for our new map is something like this. This is equals B bar plus A bar B. Okay. Here it's A bar plus A B bar. Now from this map we received this one. It's B bar plus A bar B. But is it wrong? No, it's not wrong. We haven't done anything wrong. Because of that, this resultant equation is not incorrect. Okay. This is both equations are correct. Okay, anyway, here you can see we made this horizontal group. Here we made this vertical group. Then how can we do these groupings? But if you group like this horizontal group, If you make a horizontal group, that is okay. If you make this type of vertical group, that is also okay. Or maybe if you make a square like this, that is also okay. Okay, but if you do something like this one, the diagonal, something like that, combining these two together, then this way also, these are not allowed. Okay, and then here, what about that? And in previous case, we had this horizontal group. In the second case, we have this vertical group. What about that if we have both things together? From first one, we take this one. And what is this? This is A bar. Considering this one, we can take this. Then what is this? This is B bar. Can we do like this? Then what here we have done? We have taken this one twice. Okay. We have taken this one twice. Is it possible to do that one? For the moment, assume that we have done correct thing. Then what is the resultant equation? Now our new equation says us F equals A bar plus B bar. Here that actually, if you take this one, this is our third equation. This is our second one. This is our first one. Okay. Assuming that we have done correct thing, that the meaning is that we have covered one grid many times. Then which equation is the best one? At the moment, if we assume that we have done the correct thing, what is the good equation among these three?
The first two equations.
Sorry,
The first two equations.
first two equations are correct. Actually that's why I said that assuming that the third one here that we covered this one two times, assuming that that is correct, I think all three equations are correct. First one is anyway correct. Second one is also correct. But for the moment, assume that we can cover one term many times. Then if it is okay, then third one is also a valid equation. Then if that's so, what is the most minimized one? Which one has given the good result?
The third one is the most minimized.
Third one is the most minimized one. Okay, then we will try to find a way to justify this. Okay, actually what we have done here, then this is our equation. F equals A bar B bar, A B bar, and A bar B. But here, to cover this one twice, we have assumed that in our equation, we have this A bar B bar term two times. Then from these two, we get B bar. From these two, we get A bar. But our problem is, we have done this one. This is correct or not? This is the problem we have. Okay. Is this correct or not? Then do you remember that logic identities? In logic identities, what do you say that what is A plus A? What is that? It's A. What about that if we write A plus A plus A plus A like that? Again, it's A. Then if you have AB plus AB, what is that? It's AB. Okay. Then again, if we have AB plus AB plus another AB, the result is AB. Then adding one term many times, it doesn't affect the final result. Then here we have taken A bar B bar twice, it doesn't make a problem. Okay, then we can do this one. Then if it is okay, I think this is the best equation and this is the good one. Then here, with that, we are learning first rule of Karnaugh maps. What is the first rule? One grid can be covered many times. If you want, one grid can be covered many times if it helps minimization. Remember that. It is not a must. All the time, it is not necessary to cover one term many times. But if you see that it helps minimization, then you can take. Otherwise, it is not necessary. Okay, we will have a couple of examples later on, then you will realize this one. For the moment, we can take it like that. It's okay. Are you okay with that? Yes. Then we can try 3 variables one. 3 variables one. Then we have 3 variables means how many combinations do we have? We have A, B, C, 3 variables. Okay. Then how many combinations? Then we have 2 to the power 3 combinations. That means 8. Then we need a map with 8 grids. Okay. And here, this is side A. We have A bar, B bar, and this is side BC. Then we'll have B bar, C bar. This B bar C and BC bar. Then BC. Okay, explain the previous one again here. What I have mentioned here is that to take this third equation, we have made these 2 groups. To make this A bar group and B bar group, what we have done here is that we have taken this A bar, B bar term twice. To make A bar group, we have taken. To make B bar group, we have taken. Then only we will have this equation A bar plus B bar. You can see that it's a very good one among these 3. Okay, then we want to check that is it possible or not. Then when you go to the logic identities says us, then this particular logic identity says us is A plus A equals A. The meaning is if you have one term many times, it doesn't matter. For the final results, there is no effect if you duplicate it again and again. AB, like that. Then that means that here, if you have equation like this, actually, to do this means that we have taken A bar, B bar 2 times. Assuming that in our equation, we have A bar, B bar 2 times. But actually, in our equation, we don't have that. But if you assume like that, there is no harm. Okay. Then we haven't done anything wrong. We haven't done anything illegal. Then this is allowed. Actually, that is the first rule of the concept. One term can be covered many times. But remember, if it helps minimization only, you can do this. Dinakshi, is it okay? Okay. Then we come to these 3 variables map. Here, this BC side, then B bar, C bar, B bar, C, B, C bar, B, C. But this is wrong. Why? But when you put numbers here, this is 0, this is 1, this is 0, 0, this is 0, 1, this is 1, 0, and 1. Then in this grid, this is 0, 0, 0. This grid, this is 0, 0, 1. This is 0, 1, 0. This is 0, 1, 1. This one, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. There is a rule with corner maps. It says us, when you go from one grid to next grid, when you go one grid to next grid, all adjacent grids, okay, we can change only one bit at a time. What does it mean? Here it's 0, 0, 0. Now when you come here, it's 0, 0, 1. We have changed only one bit. from downside, this is 0, 0, 1, it's 1, 0, 0. We have changed only one side, then here to here. Here to here, it's okay, no problem. And here to here, it's okay, there is no problem. Then what about this one? 0, 0, 1. Here, it's 0, 1, 0. We have changed 2 bits. Then this is not possible, this is illegal. This one, 0, 1, 0 to 0, 1, 1. Here to here, it's okay, but here we have done wrong. Because of that, this pattern is not allowed. This is not allowed. We can't do this one. This is wrong. Then what is correct? Okay. Then what is correct? If you write this one in this way, 0, 0, 0, 1, 1, 1, 1, 0. The meaning is B bar, C bar, B bar, C, BC, BC bar. That is correct. Okay. Then this is the correct way to do this. Okay. Then we can draw the correct map for 3 variables here. Okay, sorry, here that this is not B bar. This should be A. Okay, this is side A. This is A by A. Okay. Then we will draw the correct map here. This is side BC. It's B bar, C bar, B bar, C, BC, BC bar. This is side A. This is A bar and A. Okay, this is the correct. But if you want to have a different pattern, it doesn't matter. Okay. If you want to have a different one, it doesn't matter, but you have to maintain the rule. You can change only one bit position at a time. Okay. Then shall we try a problem here, an example? This is correct, and this is correct. And we will try this one. This is sample 2. Then H equals maybe Okay, try to mark this one in the map. Okay,
then
we have a
question.
Can you show example one again, please? For example one, this one. Yes. Do you have any problem here? Or maybe that you do just want to see it?
Yes, sir. Thank you. So there was an echo.
Yes, I saw your message that, but in my side that I can't do anything in that. Sometimes the connection problem may be there. Till that you hear like that. Till you hear that echo. Okay, then how can I stop that one? Maybe let me try it. Microphone. I tried. One of your friends has asked this question that one bit at a time means that when you come from one read to next read, when you go from this read to next read, you can change one bit at a time means that here the bit value is 000. When you come here, it has changed to 001. Then 000 to 001, we have changed only one bit. But 001 to 010, we have changed two. That's why here it's wrong. What can I do that then if I left from the session, then I'll not have recording rights again. Then I have to ask the I came to do the recording rights again. Then I change my audio settings also, but let me have a couple of minutes try this one. Okay. Is it okay now?
Yes, sir.
Okay, then now in this map, now we have this way. Then how can we make groups here? We can make a group combining these two. And what is the name for this one? This is A bar, because we need a support from A bar. It's on A bar row. Then we need support from these two columns. Then it's B bar. Okay, here we can cover the entire BC column. The name for this one is BC. Okay, then minimize equation is H equals A bar B bar plus BC. Okay. Then we can try this one if you're okay with this. Okay, shall we try this?
Excuse me, sir.
Yes.
In the previous one, can we group the first three digits in the first row? I mean, A bar BC twice. Can we take it twice?
A bar
BC.
BC, this one, but it's okay. But then
It will be harder to write.
yes, then is it possible to write me that answer for this one? If it is possible to name a group this, then there is no problem. Then try to give a name. It is a very good question that Dilmi is asking. She's asking that if we make this group, if we make this one, then we can cover these three things together. Then assume that if you have done that one, then try to give a name. Then covering this one, if you do like this, then try to give a name. What is this? Then we need support from A bar. Then A bar should be there. But you need support from these three columns. But there is no common thing from these three columns is coming. Because of that, the naming for this one is the problem.
Yes, sir.
Yeah. Then we can't do it. So that when you make groups, you can try numbers 2, 4, 8, 16 like that. In between other numbers, if you make group like that, then you can't give a name. Is it okay?
Okay, sir. Thank you.
Okay. Thank you for asking that type of question. It may be that it gives that, that broad understanding for your other batchmates also. Thank you. Okay, this one. Okay, before you do this one, then I'll make a small clarification here. Now, if you have a map like this, definitely that you can see this is A bar. Okay, this is A. Then this entire row is A bar. This entire row is A. But what about others? If you cover this one, what is this? Actually, these two rows are, this is B bar. This one, this is B. This, when you have a single variable, it has 4 grids. And what about this one? What is this? This is C. And if you have these two columns, that is C bar. It's together. Okay. Then shall we try this? Actually, I don't have power now. It's okay that since from the beginning also I didn't have power, but anyway that I had this battery, but it's 12% remaining. Sometimes that it might be finished that before we end up the lecture. Then anyway, that until that we can go. Okay, then how can we minimize this one? Shall we mark this one first? A bar, B bar, C bar is this. A bar, B, C bar is this. A, B bar, C. Then A bar, B bar, C, A, B, C. Okay, then how can we make groups? We can make this one. What is this? This is A bar, B bar. And this one also. What is this? This is A, C. What about this one? Then we have to take it alone. Now we have other way. Okay. Then we have other way. The meaning is that we can cover up this one with this grid, assuming that they are close. How can we assume like that? If you take this edge on top of this edge, consider making a cylinder, making a vertical cylinder, you can take this edge on top of this edge. Then when you do like that, then this grid and this grid, they are close. Okay. Only the thing that we can do it, obeying the rule. You may remember that when you go from one grid to next grid, If we change only one bit, then you can do it. According to that rule, we can do this one. Then try to give a name. What is this? It should be A bar. And what is common from these two columns? That is C bar. Okay. Then this minimized equation is the minimized equation is H equals A bar B bar AC plus A bar C bar. One question is, can't we create another vertical group by combining B bar C and A? B bar C, you mean that this way? But it is not necessary to combine this. We have already covered all ones there. Then after that, it is not necessary to make another term, another groups. But whatever the way that you have to cover all ones there, if you do it, if you have covered all ones there, it is not necessary to make another groups. It may be redundant. It gives that additional terms. Okay, shall we try this one? Yes, we can use one twice, but it should be meaningful. I mean that you are asking that to make a group like this. But in my case, it is not necessary. Why? Because I have covered all ones there. All ones I have covered. But if you do like this, then we have to make this group also. Then 1, 2, 3. Another 3 is coming. It doesn't matter. You can have that solution. But in my case, it is not necessary. In your case, it's okay. In your case, that you can make this one, and then you can make this one, and to cover up the other one, then you can make this. Then again 3 groups. It's okay. That is also possible. But in my case, that one is not necessary. That's why I mentioned. There may be several other solutions. It's okay. But you have to cover all ones there. Once you cover, you can cover it again if it is necessary only. If you do like this, then we will have a different equation. If you do like this, then we have a different equation. Then this one is A bar C bar already there. Then this is AC is already there. And this only B bar C is coming new. This is I'll write this, otherwise that in the later time when you look at this one, you may have a confusion. Okay, let's try this one. A, B, C, then A bar, B bar, C bar, B bar, C, plus A, B, C, A bar, B, C. Okay. Because I am losing my power, it's 6% remaining. Then before that, I'll write this. Then you can try this one. B, C.